Hello everyone and welcome to the session number 6 of our course Databases Design and Implementation. Today I will introduce the conception of relationships. I presented it previously when I explained how to draw the ER diagram, but today we will learn how we can convert these relationships into code, how we can identify these relationships using SQL statements. Before everything, I want to introduce some constraints in SQL. Not all the constraints, just the constraints which are very important to identify the relationships. First one is the primary key. The primary key is a unique identifier, ensures each row has a unique identifier. This primary key cannot be null and must be unique. So here we have two constraints. First, cannot be null, and the second is unique. For example, we cannot find two students in the university with the same ID. The ID of the student should not be null. We should not find any student in the university without ID. So we have two constraints with the primary key. The first it should not be null, and the second, it is unique. How to write this SQL statement? For example, when we create a table, let's say we will create the student table. So here we have this students table. We can present one attribute as primary key like this, student ID, it's integer, and this is the primary key. Then we have other attributes. For example, here we have the name. We can have more attributes like address, email address, like real address, like hobbies. We can have a lot of things in this table, but as example, we have here just the name. Second constraint is the foreign key. Foreign key is used to connect a column to a primary key of another table. And this foreign key will be helpful to ensure the integrity between several tables together. For example, ensures that every student ID in enrollments table must already exist in the students table. For example, here we have this enrollment table. We have enrollment ID, which is primary keys, and student ID, which is integer. And here we are connecting the enrollments table with the student table using the foreign key. So if we write here one ID of student and it's not existing in the student table, we will have error. Okay, so this is the second constraint. Then we have the unique constraint, ensures that all values in a column are different. For example, name of courses in the faculty. We should not have same name of two modules or two courses in the same faculty. In two different systems or in two different faculties, it's possible, but in the same faculty, we should not have the same name of module, for example. It's not like the primary key. We can apply the unique constraint on multiple columns, and it can be null. For example, the email of the student, it's unique, but it can be null. It can be null if it's not mandatory for the student to add his or her name. Okay, so how to identify or how to introduce this unique constraint using SQL statement? We can write it like this. For example, here we have email for users, which is varchar length 100, and this is unique. So it should be unique, but it is not mandatory. How we can see this in the reality? Sometimes when you register for something like for Amazon or something, so in the registration sheet you can find some attributes with like red star, for example, and they will say everything with red star is mandatory, and the things without red star, they are not mandatory. So you can add and you cannot add. For example, the photo, it's not mandatory. You are not forced to add photo. Sometimes the email, sometimes the telephone number. For some companies, the email is mandatory, and even sometimes you need to do the email verification, but for other companies, maybe it's not mandatory. It depends the company and their rules. Okay, so this is the unique constraint. Not null. Also, not null is one of the constraints. Sometimes the value in one column should not be null. So we can add this constraint like this. For example, if we have this table, like books in a library, for example. So for each book, we will have the book ID as primary key. The title should not be null. So we can do this using not null constraint. So we can write title varchar not null. Every book must have a title. Another example. Here we have the in the table student in the schema university. If we have already identified the schema or created schema. So we have the student ID, which is primary key, name should not be null, email, it is unique. So we can add several constraints for the same table. Understanding the relationships. I previously presented the relationships, and I said we have several types of relationships. The first one is one-to-one relationship. The second one is one-to-many relationship, and the third one is many-to-many relationship. Let's just remember what's the meaning of these relationships. The one-to-one relationship means each row in a table A should be related to one and only one row in table B. For example, about the one-to-one relationship, we have the relationship between the user, and the profile of this user, the user's profile. Each user should have only one profile, and each profile is connected to only one user. So this is the one-to-one relationship. How to convert this relationship using SQL? We can do this using two constraints. The first one is the foreign key. The second one is the unique. Later I will show you how we can write these statements. and how we can identify this relationship, the one-to-one relationship. Second one is the one-to-many relationship. The meaning, the row in a table A can be related to many rows in table B. For example, the relationship between the authors and books tables, the authors table and the books table. Let's say, I know it's not really very correct, but let's say one author can write several books, but one book cannot be written by several authors. So one book is connected to one author. One author can write several books. And I know that in the reality, the book can be written by several authors, but let's say this just to understand this relationship. How we can present this relationship using SQL? We can do this by writing foreign key in the many table. In this case, we can add a foreign key to the book table and connect this books table to the authors table. So this is the one-to-many relationship. And now what about the many-to-many relationship? To present this relationship using SQL, we cannot do it simply like relationship between two tables. To present the many-to-many relationship, we need to add new table, and this table will be the will connect these two many-to-many tables together, and we can call this table the junction table. For example, here we have students and courses. This relationship is many-to-many relationship. The meaning, one student can study a lot of courses. One course will be studied by several students. So the relation here is many-to-many relationship. In order to present this relationship using SQL, so we need to add junction table. The junction table can be, for example, the enrollment table. And to show this using SQL, we need to add two foreign keys in the junction table. So inside the junction table, the enrollment table, for example, we need to add first foreign key to connect this enrollment with the students, and second foreign key to connect this enrollment to the courses. How to write the statements, how to write the SQL statements. Let's imagine that here we have two tables. The first one is the students table, and courses table is the second. For example, if we add these attributes to the students table, here we have the student ID as primary key. We have the name should not be null, not null. We have email, it's unique and not null. Okay, here we have another L. And age, which is integer. Okay, we have another table, courses. We have the course ID as primary key, course name should not be null, and credits for each course, it's integer. Okay. In order to connect these two tables together, I told you we need to add third table as junction table. And how to present the many-to-many relationship. After writing the attributes for the enrollment, let's say we have enrollment ID as primary key. we should add how to connect this enrollment to the students table by adding here the student ID, how to connect with the courses table by adding the course ID, okay, and other attributes of the enrollment. And then we need to add these two foreign keys, one to connect the enrollments to the students table as reference, and the second to connect the enrollments to the courses table as reference. By this way, we can identify the many-to-many relationship using SQL. Just a notification, sometimes instead of writing the primary key, not just for this table, in general, instead of writing just integer primary key and adding this ID, for example, every time for each enrollment or for each student, for each course, for each user, we can just, if it is integer, we can just write like this, auto increment primary key. So by this way, we will skip the errors. We will be sure that the ID will be incremented automatically. So just a notification if you want to add the ID automatically, not manually. So this is the many-to-many using SQL. And now how to write the one-to-one relationship using SQL. I told you we need two constraints. The first is the foreign key and the second is the unique. For example, here we have users table and user profiles. I told you this is one-to-one. User can have only one profile. Profile can be related to only one user. So after creating the table user, how to connect it one-to-one with the user profile? By first here writing user ID, integer, and this is unique, even in the profiles table. And we can add here the foreign key and reference this user ID to the users table and the user ID in the users table. And this is how to write or how to convert the one-to-one relationship using SQL. Last one is the one-to-many relationship. This is the easiest one. So, for example, for the same example, authors with books, and be careful. Maybe this is not the optimal example, but just to tell you how we can write this statement or how we can use SQL to convert this relationship into code. So here we have the authors table. We have the author ID in the first table, which is primary key. In the second table, I should mention the author ID, okay, to connect this books table to the authors table. And also I need to have, I need to write the constraint, which is the foreign key, and with reference the authors table. Also to remind you, I told you previously that this foreign key should be added to the many table, and in our case the books is presenting now the many table. So this is everything for today. We learned how to convert the relationships, different types of relationships, into SQL code, and how to present these relationships in order to keep your database correct and to keep the integrity of your database and to avoid the mistakes and errors in the future. See you with another session of our course, Database Design and Implementation. Bye bye.